And welcome back. Now today we have here a broken Arduino, broken in the sense that its USB port doesn't work anymore. So whether that chip's broken or the crystal's cracked or something, who knows? Now let's just have a quick shout out for PCBWay. They've been around for 6 years now and they're celebrating their 6th anniversary. And without companies like PCBWay, where would we be? Let's have a look to see what they're offering. Okay, here's their 6th anniversary page, and you can see they're having a big mid-year sale. Now's the time to get your PCBs in, really, whether you're going to have them assembled by PCBWay or just the bare boards. Have a good look, because if we scroll down a bit on this page, you can see they've got lots of free coupons and offers, and keep scrolling. There's lots of information on here, and even best, yeah, this will help me. Look, if you go down far enough, you'll see lots of messages from people who are wishing PCBWay all the best for the future. And look, there's me. It'd be great if you could say, yeah, thumbs up on that one. You know, it's all a bit of fun, isn't it? So don't forget, PCBWay's 6th anniversary celebration. Go and have a look, see what there is for you, all those special offers and things. And if you have never done it before, believe me, it's much easier than you think. So go and have a look now. The point is, I had a query from a viewer saying this is exactly what's happened to him. And how can he upload another sketch to this device now? He says the sketch that was on there is still running, as is this one here. Yes, I know, we have that lovely blue LED in there without a resistor. Shh, don't tell anyone. So obviously the Arduino itself is okay, it's just the USB bit that's broken. So I explained to him, I says, well, one of the ways you can do it if the USB is broken is to get another Arduino, load a special sketch on here that's already been supplied by Arduino themselves called Arduino as ISP, which turns this other good one into a programmer, and then you connect these 6 pins here, the ICSP. In fact, that's not, it shouldn't be ISCP at all, should it? It should be ICSP, in circuit serial programming. Oh dear, never mind. Anyway, so you connect these 6 pins here exactly the same to the 6 pins on this one, which is over here. Okay, 1 for 1. You don't cross any over, you don't move any, and in fact normally you'd use a standard 6-pin cable like this one here, and you can buy these separately, but normally they come with programmers. If you've noticed, I've put a red splodge on that side because sometimes it's quite difficult to know where pin 1 is, so you've got to keep pin 1 well, oriented the same way, really. Whichever way you plug it into here, you've got to plug it into the other one the same. So having loaded up the sketch on here, connected up your cable, you then can load up whatever sketch you want on here, and it basically bypasses the bootloader entirely. Which may be, you know, okay for you, but the problem is, even though as I was writing these instructions to him, which you can probably read in one of these comments, you know, I thought, yeah, you can load up the sketch okay, almost certainly, because these 6 pins, they're only the same pins as what you find on the outside, but they're just grouped together to make it more easily accessible. They're connected directly to the actual chip, so you're splatting over the top, right, in SPI mode, basically. I thought, yeah, you can do that, but then of course you haven't got access, have you, to the serial ports, so that you couldn't do a serial.print, for example, and find, you know, to debug and find out what the values are of the temperature in your beehive or whatever it is you've got running. So I thought, and then he came back to me and he goes, I've loaded up the sketch onto this one, so have I got to load up the sketch again to that one as well? I'm thinking, oh, this is just getting more complicated now than a simple answer would suffice. So I thought, right, I'm just going to tell everybody, okay, what to do if your USB is broken and you know you just cannot use this bit at all, how to load up a sketch. Now I'll go through using ICSP, which I use all the time in my projects, because I do not want to use the bootloader, because the bootloader is slow and it gets in the way, but I do still use the USB for serial.print. Now if you want to use an Arduino as an ISP, that is a programmer, get a good Arduino, load up the sketch called Arduino as ISP on it, and then connect that UNO via this 6-pin cable to the UNO that needs uploading to, also via the ICSP cable. 6 cables. If you haven't got a cable, DuPonts would do, but one, they're not brilliant to fit onto those sockets, and there's room for error then, isn't there? One of those cables will only cost you a few pennies, to be quite honest. Go for somewhere like AliExpress for that. Now when you upload, do not forget to say upload using programmer. You either have to press shift and the upload button, or sketch upload using programmer. It's too easy to forget, and then what you're going to do is upload your sketch not to this one, it will just come onto here instead, and then you'll wonder why your Arduino is no longer running as an ISP. Easy done. So just having the ICSP to load up a sketch is only half the story, isn't it, really? And there's a gotcha even in using that. The number of times I've uploaded the Arduino as ISP sketch to here, I then forget to say upload using the programmer, and you splat your new sketch all over the top of the one you've just written the Arduino as ISP to. Yeah, I know, we've all done it. We've all done it. But when it works and you're awake, which takes me some time, then it works wonderfully well, and it's been running for years and years. But I thought, okay, your serial port though is foobar, as they say. So I thought, okay, the alternative, the obvious alternative, which I've shown you guys many times with my bare naked Arduino UNOs, well, they're not, they're AT328P chips really, with the absolute minimum on them. It's got like a crystal, a couple of caps, and that's it. And we use this FTDI thing here that I've got. So this is a standard FTDI. You've got power, you've got ground, so VCC, ground, TX and RX. The TX on here goes to the RX on here, and the RX on here goes to the TX on here. So they swap over, okay? You mustn't forget that. And the one final pin on here, the DTR, which is like the reset pulse, as given out by your Arduino IDE, you would think goes to the reset over here, wouldn't you? Well, if you wire it up this way, you'll be disappointed, frankly, because that just will not work. In fact, I'm going to show you what happens when we do wire it up like that, just so that if you ever get it, you'll see the result and you go, ah, I saw this once in one of Bacon's videos. I know, yeah, he told us the answer as well. Okay, let's just show you it wrong and then do what we need to do to make it work. Okay, so what we've got here is just a simple little sketch that flashes the LED in a different flash rate to what it's already flashing, just so that if it does upload, we can tell it's done something. Okay, so I've already pre-compiled, as you can see here, it's worked. It's about 5 lines. So if we just say upload, that's connected to port 4, which is what the FTDI is connected to. And this replaces, that FTDI replaces the front end of your Arduino board. You're doing exactly the same as what the built-in bit of the USB port. Now on a standard Arduino, a proper kosher Arduino, it's a 32U4 chip you got on there, which is expensive and well over the top, which is why all the Far Eastern and Asian brands decided they were going to use initially an FTDI chip and secondly a CH340G chip, right? USB to serial converter, which is basically what we're doing now. We're doing it manually, aren't we, that way? So let's just see what happens then if we try and upload using that particular configuration that I've already got with those pins connected. Right, here we go. It's uploading. It's incredibly slow, this Arduino IDE. I don't know why. It's 1.8.13, and there isn't a newer one. I've already checked, but it does seem to be taking its time these days. Right, so it's trying to talk now to the FTDI. The FTDI in turn is, you know, trying to get hold of the Arduino. Basically, it's trying to give a reset pulse to the Arduino, and as you can see, again, it's not working. Now I can tell you now this isn't going to work, so we're not going to wait here for all 10, because once you've got stuck in this loop, nothing you do is going to make it work. So you might as well pull the plug and move on. So let me show you now what you have to do to get this configuration to work. Right, okay, so as I said, it wasn't going to work, so we've skipped all that bit. So let's go back to the workbench just to see what changes I've made. And as you can see here, the reset pulse from DTR on here is now going through a capacitor. In fact, it's going through 2, and I'll tell you why. If you've looked at any of my naked bootloaders and things, you'll see that I use a 100 NF capacitor between the DTR and the reset pin of the Arduino. Now here though, I tried 100 NF, which is the standard one to use, wouldn't work. Well, it just didn't work. We got the same error as we had, or it says it's not in sync or something. I don't know, can't remember the exact error message. And then I scoured the internet and it says, oh no, I've discovered you need a bigger capacitor, 1 microfarad capacitor. So I thought, well, I'll just put it in parallel with the one I got to see if it makes any difference. So let's whiz back to the coding page, and there we are. Let's try it again. So we just hit the upload button as we would normally. Once again, it goes through the rather tedious actions of compiling most things. See, what's it actually doing at this point? We're pausing, and what's it doing? There's just no code to actually upload. Come on, faster, faster! Luckily, Arduino CC are actually developing a brand new Arduino IDE, which you may have seen from some of my previous videos. Right, now it's saying, ta-da, look at that, it's shooting across. Now, if we go back to the workbench, there we are, look. Do we get? Yes, now we get a lovely double blink. So, okay, let me draw out these connections on the whiteboard for you so you can see exactly how this works. And it's only one capacitor. You don't need that 100 NF, by the way. It's just the one microfarad we need. So this is the very simple circuit when connecting your FTDI to your UNO, or Nano it could be, I suppose. The only thing to watch out then is from the reset pin on your UNO, it has to go through a 1 microfarad capacitor all the way back to DTR. The RX swaps over and goes to the TX, and the TX on the orange line here goes over to the RX. VCC and ground are self-explanatory, and we don't put anything on CTS. DTR incidentally means data ready to send, and CTS stands for clear to send. No, I don't know what the differences are. These are all sort of pseudo modem signals, I think, really. But DTR is used to generate the pulse to reset your UNO so that it goes back into bootloader mode and can accept the incoming sketch. And I'm thinking, and it's been going around my mind for a couple of days now, it would be easy to create a shield for this. And I don't mean going off and creating a PCB, although you could do that, of course, if you were in the market for making lots of them. I'm just thinking one of those shields made out of sort of perforated board, with all this stuff sort of pre-wired, so you can just plug in one of these FTDI units directly into that shield, and Bob's your uncle, you know, have all the capacitor already on there. Now, the one I've got, I'm just trying, here we are, is over the top. We don't really need something like this. Now, this is a shield that plugs into an Arduino, but it's more of a development, you know, prototyping shield. There's space for chips, and it's got a couple of buttons on here and a couple of LEDs and all sorts of stuff. And I thought, that we don't need all that. Yes, it would work if you use this, but we don't need all that just to bypass the USB bit of that Arduino. So let's have a look on Banggood and see what else you could probably get. Now, don't be put off by the initial price here. It says $9.25, but you do get 5 boards, and I couldn't find an individual board for sale. I guess they're too cheap. But as you can see here, it's a pretty plain board, isn't it? And it's just perforated. It looks remarkably like the one that I just showed you without any components on. There are some better ones though. If we go over to here, so this is actually these. Oh, I didn't realise that price. But yeah, okay, for $18 you get 5, and these are now just standard boards. Look, you see that? You know, they got the pins on there, or room for the pins, and then it's just a perforated board. That's for 5 of them. Perhaps you can buy these individually. I don't know. I was looking around for individual ones. Now here is a board. Look, this is 89 pence plus 119. It's an individual board now, which is probably a cheaper option if you just want one. I think it's the right pitch. It says here, yeah, 2.54 pitch. I think that's right for the Arduino R3. That's it. So there's obviously stuff out. This is on eBay, by the way, this one. Some of those prototyping development shields come with this sort of breadboard as well, which can be useful, but not particularly, I don't think, for this circuit. But you might find it useful just to put the capacitor in without having to solder anything. It's an option, isn't it? Okay, that's enough for this. While this works and is obviously the way to go, rather than using the ICSP pins, because then you've lost your serial port, haven't you? So let's just have a look at the sketch and prove that this is all going to work. Okay, with the serial, I mean. So we've got all this in here. Let's put in a couple of serial statements into this sketch, shall we? Right, we've just got a couple of lines put in here. This is just in the setup, just to prove that it works, really, having done all this. So we can upload that using the exact same mechanism what we just used. So when this wakes up, come on, Arduino, wake up. There, let's go. Is it my computer, or has the Arduino IDE suddenly gone slow? You see, I don't use the Arduino IDE very much at all, mainly for demos, funnily enough. We'll fire up the serial monitor to get that as well in a sec. And there we are. That's it. So the setup completed. So at least this way, using the FTDI with that capacitor on the reset, 1 microfarad capacitor, the serial will work as it always did, and you can use your Arduino no trouble at all. So there we are. Now there's just one little thing I'm going to show you, which I played about with just well, for demo purposes on that sketch. Let's have a look at that. Now the line I've added into the sketch now is this line here. What I'm creating is an array of integers, and I said I want 1,000 of them, please, and I'll initialize them to 0 as you create them. All right, so that's going to be, if there's 1,000 integers, and an integer, as you know, is 2 bytes. So that is actually 2,000 bytes that I'm trying to reserve, which is, well, far too much. You've only got 2,039. Well, you've got 2K. Minus a couple for a bit of overhead, so 2K. So this is not going to work, is it? Because I'm reserving here 2K of SRAM runtime memory just for this one little array. So let's just compile that and see what it says. I'll speed this bit up again. There we go. So what it's saying is my sketch is 2,000 bytes, that's fine, and we've used 204 bytes. Oh. What happened to the 2,000 bytes then of my dummy integer array here then? What happens if I take it out? How many bytes did it take initially? Let's do that again. Remember, it's 204 bytes at the moment and 9%, okay? Well, blow me down with a pink feather. Look at that, 204 bytes with 9%. So does it mean the compiler has just totally ignored what I've asked it to do then? After all, I've said give me an array. And it goes, no. Well, the compiler hasn't said no, actually. What's happened is the compiler has optimized this code. And this is, you can get various degrees of optimization in code, but by declaring a variable like this and go, I want 1,000 integer entries in an array, please, at 2 bytes each. When the compiler has finished compiling, there's an optimization phase, possibly done via the linker, and it goes, but you haven't actually used this huge big array, and it got all this memory. You've not used it. It's unreferenced by anything. So I'm just going to quietly remove that and take it away, which is great, because anything that you do declare, if I declared, 50 variables now somewhere up here and never referenced them, the compiler would quietly remove them so they didn't take up space, which is sort of a double-edged sword, isn't it? Because it gives you a false sense of security that you can do all this stuff and it has no effect on the final code, but of course it does. Now, under what circumstances then would it actually say, oh, you are using this then? I'd better leave it in, and then probably fail the compilation, I would think, quite honestly. Well, let's have a look. Right, so what I've added in here then is to say I want you to print me the output of the 50th element of this 1,000 element array, and we know it's going to be null because we've initialized it up here. Is that enough to keep it in circuit? It was going to go, no. Well, let's compile and find out again, shall we? Oh dear, it still says I'm using 204 bytes. Basically, it's not going to do it. Interesting. So under what circumstances is it going to give me this array? Well, let's perhaps set the value rather than just having this initialized array up here and then printing out one of those values. I guess what it's doing here, you see, where it says dummy 50, it goes, I can work out that in fact you've done nothing to this array. I'm just going to substitute dummy 50 here with a null value because you've done nothing. So let's set something and see if that makes a difference. So what we've done now is set dummy 10, the 10th entry in this array, to the life, universe and everything answer of 42. Is this going to make it keep that array in memory for me? Let's have a look. Oh look, not enough memory. Because we're trying to use now 2,204 bytes, which is 107%. So finally the compiler or linker has said, do you know what? I can't optimize this huge big array away anymore because you're setting a value here and you're printing it out. Just printing it out was enough. It could substitute the value in there quite happily. So the optimization from the Arduino IDE, or at least the AVR Dude program, is pretty good, isn't it? So you never quite know what's going on in your program. Even though you've said, give me an array, you won't get one. Even though you've said, and print me the 50th element of that array, no, you still won't get one. It's only when we start writing to it and then reading from it, it goes, oh, you really are using that array, then all right, I'll leave it in and not optimize it away. And there's various levels of optimization. I guess this is the standard one from Arduino. They've decided on this one. You can change it on the AVRDude command line, but let's not go there. After all, I'm aiming this at beginners at the moment. So just be aware that sometimes things can get optimized away and removed without you even being aware. That also includes code, by the way. If I was to write another function here that was not used at all, so if I said function this does nothing, and even write a whole load of code in it, although it would get compiled initially, the linker and or compiler would say, you've not actually referenced this big chunk of code. It will never be executed. I'll quietly move that out of the way. And you have to be careful of that, because you think you're writing code and it's been compiled adequately. You think, oh great, I've got loads more space, and of course it's not the global variables then you have to worry about so much. It's this sketch value that would go up, except it wouldn't be going up. And then suddenly you make a call to that function sometime later in your development cycle, and it goes bang, I haven't got enough space, or I've used up suddenly 20k of your space. So there we are. The optimization is a double-edged sword. Very clever though. It tries to keep the program as small as possible. The other thing that optimization can do, and you can force it even in the Arduino IDE, we won't go there, I'll just tell you about it. What you can, if you had a function that said display the value 42, right, and you called that function many times throughout your code, you go display value, so you're calling it many times. Now the compiler would see that this is a call to another function, and what would normally happen is that you'd have a jump to the function, it would execute the code to display 42, jump back again, and all this jumping about means it's got to put stuff on the stack, go and run the little subroutine, if you like, the function, come back, restore the stack to what it was doing, what it was before, so it could continue running. And that's pretty inefficient. What you can actually say is, I want you to inline all these calls, so that what it actually does, it copies that function, the display 42, in your code as though you had written it in a monolithic fashion, which might not sound very efficient, but it actually could be. As I say, all this putting stuff on the stack so it can jump away and do stuff and then come back and restore the stack is an overhead and costs, well, it costs time, but B, it costs memory as well, whereas putting a little bit of code in line wherever you've happened to have called it can actually save you speed and memory. It's something that we might explore going forward in a future video. Right, okay, I think this little device now, this Arduino, is up and running even without the USB bit working, and that's a very simple hack there, if you like, but putting the 1 microfarad capacitor is enough to ensure that this Arduino can still be used even though perhaps this USB bit is blown up. Obviously, if you do blow the USB bit up, you could replace whatever chip there is on there if your soldering skills are up to it, if you think that's what's done it. But it could be so many things. Could be the crystal, could be the capacitors, anything really. But it'd be a shame to throw away what is otherwise a perfectly good Arduino just because this front end bit didn't work, when we can substitute with an FTDI or a CP2102 or something similar like that, and a 1 microfarad capacitor. Cool. Okay. Well, if you like this, do give it a thumbs up so that YouTube know they should be recommending it to more Arduinoites who are wondering what to do with their Arduinos with broken USBs. And I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.